And then split the paper into 4 sections. So on the back of the Wednesday paper, we're going to do this. And we're going to create what's called the Frayer model. So I'm going to put the definition up in the top left-hand corner. And then top right corner, we'll put characteristics. Down here, bottom left, we're going to put examples. And then over here, non-examples. Right, so defining what a linear equation is, it is a relationship that has a constant rate of change. Constant rate of change. And the graph looks like a straight line. Graph is a straight line. Constant rate of change, graph is a straight line. So under characteristics, let's put our different forms of linear equations. So what's one form that we learned about last semester? Either the name of it or the equation itself. Good. What is that called? Yeah, slope intercept. Is y equals mx plus b. And what are the 2 letters in there that we need to replace with numbers? Good. M and b. And what does m tell us? Yeah, it's our slope. What does b? Y-intercept. Hence the name slope intercept, right? Because we can see our slope and our intercept, our y-intercept really easily from y equals mx plus b. What's another form that we talked about? Yeah, good, standard. What is standard form? AX plus BY equals C. And the third form? Point slope. Anyone remember point slope? That's standard. Yeah, exactly. And what does m tell us in this equation? Yep, m is the slope again. Do you remember what x1, y1 tells us? Yeah, it's a point. It's a point on the line. x1, y1 is a point on the line. Okay. And again, that's where the name comes from. We can tell a point and we can tell the slope from point slope form. So let's remind ourselves how we graph each of these forms. So under examples, let's do slope-intercept y equals 1/2 x plus 3, let's say. Y equals 1/2 x plus 3. It's kind of annoying. Think about what's the slope and what's the y-intercept of this equation. It's my slope. That's 1/2. 1/2. Right? That's my slope, the number attached to the x. And what is b? 3. Okay. What does a slope of 1/2 mean? Good. Up 1/2. So now that I identified those two things, we can graph it. I'm just going to do like a really rough sketch of a graph. And what do we start with when we're graphing from slope-intercept? Yeah, we start with the y-intercept. So I go up to 3 on my y-axis. Let's pretend 3 is right there. And then my slope says to go up 1/2. I'm going to go up 1/2. So that means my line kind of looks like that. And then if I have a standard form equation like this, 2x plus y equals 4, what do we do to graph from standard form? Perfect, yes. So we are going to rewrite this equation in slope-intercept form, and we do that by getting rid of this 2x, that x variable. I want to move it to the other side. So so we're going to subtract the 2x from both sides, because that will eliminate them there, and that'll make y all by itself. And then can I combine 4 minus 2x and get 2x? No, right? They're not like terms. So it just stays as negative 2x and a positive 4. So then what's our slope? Very good, negative 2. And what's our y-intercept? Positive 4. So now same thing, I'm going to start by plotting my y-intercept. So I go up to the 4. And then my slope is negative 2. What does that mean? Yes, it is going down, but down how far? 2 and over how many? 1. Okay, down 2 over 1, so I'm going to go down 2 over 1, and it'll look something like that, right? And very clearly, that first line I drew had a positive slope, the second line I drew had a negative slope, right? Okay, and then let's do a point slope equation too. So let's say y minus 3 equals 2/3 x plus 4. What is my slope? Good, 2/3. Write that better. Okay, the 2/3 tell me my slope, right? Which just means up 2 over 3. And then what's going to be, we need to identify the x1 and the y1. I agree with you, y1 is 3, but I don't agree with you that x1 is 4. It's negative 4. So it's always the opposite sign of what you see in the equation. So this looks like a positive 4 in the equation, so the x-coordinate is negative. The 3 looks negative in the equation, so the coordinate is positive. It's the opposite of what you see in the equation. And this point is where we start. So I'm going to go to -4, 3. It's like right there-ish. And then my slope says to go up 2 from here and over 3. So I don't know, that's about right there. And I've got my line. Any questions on that? Anything you want me to explain again? Okay. So then a non-example would be anything that is non-linear. Anything that's non-linear, which there's a more non-linear types of equations than there are linear types of equations. Right? There's like the sine and cosine curves that look like this. That's one. You wouldn't look at that until like pre-calculus, so. But that's one type. There's also like rational functions that kind of sometimes look like that, something like this. We also, you can just draw like a squiggly line, you know, that's fine. But basically, as long as it's not straight, it could be, it's not going to be a linear equation. But then specifically, in our next unit, this unit is all about linear equations and linear inequalities. But in our next unit, we look at exponential equations. So it looks something like this, where I have x as an exponent. Not as scary as it looks. We'll get there, don't worry. But the graph looks like this for an exponential. And have you heard that before, exponential growth? Yeah? Or have you heard about compound interest before? Do you know what compound interest is? Can I show you this really quick? Just for the sake of it, let me crunch that out so you can still take notes. So let me show you this. So let's say you get $100 from your grandma for your birthday or something. Okay, so you have $100 that you're starting with. And if this would be an example of a linear equation. If I make $25 a week, I like walk a dog or something, I don't know, babysit, right? I'm gonna add $25 to the amount of money I have. And every single week that I work, I'm always gonna just add that $25 every time, right? So after 1 week, I have this much. After 2 weeks, I have $150. 3 weeks, 4 weeks, 5 weeks, 6 weeks, and so on, right? But when we have exponential growth, in the business world, we call it compound interest, we would take that $100 and instead of just adding the same amount every time, it's going to grow by a percentage. And when it's a small amount of money, like $100, you don't really see too much of a difference. So let's do the same thing for 6 weeks, and we're going to make this grow by 4%. So after 1 week, we have only $104, right? Oops. Times 1.04. After 2 weeks, it'd be 108. After 3 weeks, you have 112. 4 weeks, 116. Sure. So clear y equals 1.04 raised to the x. I need to change my window. -1 to 10. Count by ones. -1 to 10. Why is it not doing that? Oh, because it was 100. That would be why. So let's go 0 to 150, and we'll count by tens. And then I want to go just 0 to 10. Hold on one sec. It takes me a minute. Count by ones.
Can you guys please release the city boys basketball team? Thank you.
Why is this not doing it? 1.04. Aha, I know why. No. Why are you not working? Times 1.04 to the x. Window. 0 to 10, count by ones. Let's count by twos. 0 to 250, count by okay, I'm not getting the window to work out. Sorry. Never mind. I can't do it for you. I can, but I'll show you tomorrow. But let me show you this because I think this is where it gets like interesting. So when I start with $100, the compound interest, it grows, but not very quickly. But if you have like $1 million, look at this. 1, 2, 3, 1, 2, 3. This is like a totally like, I mean, not normal for most of us, but someone like Jeff Bezos' kids, he probably just gave them $1 million at one point because he has like billions of dollars. Or Donald Trump famously received like $1 million from his dad or something. If you have that in a really regular bank account, will gain 4% interest per year. So watch this. If you take $1 million and it grows by 1.04, it grows by 4%, in 1 year, you will now have $1,040,000. So you just made $40,000 doing absolutely nothing. Well, but if you put the $1 million in a bank account and you didn't touch it, let's say you have like, again, like this example, I received a gift. My grandma is really, really rich and she never told me until just now. And she just gave me $1 million. But I have my regular job, so I get money every month from my regular job and I live off that money every month. But I have this $1 million sitting in a bank account. In 1 year, that money will make 40 grand. The amount of money that most people make in a year, working really hard. Those people just made it, literally not doing anything. Yeah, so savings accounts also gain interest. If you already have a savings account open or when you want to open a savings account, something to look at is a high yield savings account because it grows faster. Like most typical banks will make like 1 or 2%, but a high yield savings account will make like 4. So anyway, I like these exponentials. I think they're fun. But let's keep going. So exponentials we'll learn about, and then we'll also learn about quadratics. And that's going to be like our very last unit. Why? It looks like this, and the graph looks like a parabola is what it's called. It looks like that U-shaped, which shows up a lot in like physics classes, science classes. They're like very relevant to our physical world because anything that goes up, right, has to come down. But it doesn't just go straight up and straight down, right? If you throw a ball, it's gonna make that U shape. So, really? Cool. Okay, so that's all we need to write down on there, but I do have an exit ticket for you to do with these last couple minutes. So can you come up and grab a sticky note, please? Let's see how many. I might have to get a little bit more.